Okay, let's look at this question on electromagnetic induction from November 2018. It says, in the simplified AC generator below, the coil is rotated clockwise. Now we know this is an AC generator because can you see we have the complete slip rings here. Okay, now it says to you the coil is rotated clockwise. This way is clockwise. It says in which direction does the induced current flow in the coil? Choose from X to Y or Y to Z. Can you see here is X and here is Y? So we have to pick which direction this thing is going to go. So we know that field lines, can you see? Here is the North Pole. So my field lines are going to be going in that direction. The coil is going clockwise. So if you look at this coil in this position here, it is actually going up at the moment. And we want to figure out in which way is the current flowing, which way are the electrons flowing. So in order to determine this, we have to use the right-hand rule. So you must put your fingers in the position of the right-hand rule, make your physics gang sign, put your thumb up, your first finger out, and your second finger the other way. And if you wiggle your finger around in the correct orientation, you will see that the current, the induced current, not the electrons, is going to flow in this direction. So the answer here is from Y to X. Okay, can you see this? Your field finger is going to the left, your thumb is going up because that's the motion, and that leaves you with the current finger. The shocking finger will be coming towards you. On which principle or law is the working of the generator based? That's Faraday's law of electromagnetic induction. So you must write that out. State the energy conversion that takes place when the generator is in operation. Well, we are generating electricity. So if we are generating electricity, we are going to electrical energy. Okay. What are we starting with? We have to be turning the coil. So we are starting with mechanical energy, or you could say kinetic energy, but it's more mechanical energy. Okay, now it says to you, the voltage output for an AC generator is shown below. Write down the maximum peak voltage of the generator. Well, this is easy enough. What is the highest value, which is the peak of the graph? This is 340 volts. Okay, it says a stove is connected to the generator above and delivers an average power of 1600 watts. Calculate the RMS voltage delivered to the stove. Well, remember, RMS stands for root mean square, because if we want to do any calculations from this sine curve, as you can see, if we average the sine curve, the average of the sine curve is going to be 0. And 0 is not a useful thing to be doing sums with. So what we have to do is we have to work on the root mean square voltage. So if you square the curve, all your negative numbers become positive. So the root mean square, we have this formula to work from. Vrms, the average voltage, is equal to the maximum voltage over the root of 2. So Vrms is going to be the maximum voltage, which we read off the graph, which is 340 volts over root 2. So this gives you Vrms is 240,42 volts. So now once we've got an average voltage, we can actually do more calculations with it, because it says to you now calculate the resistance of the stove. So what do we know? We know voltage and we know the power over here. So we need to find a formula that connects these two. So we have this one. The average power is equal to V squared RMS over the resistance. Remember, this is just like the DC formula, but instead of working with straight numbers, we're working with average numbers. So the average power is 1600 watts. The voltage RMS is 240,42. We just calculated it, so we have to square that divided by R. That is going to give us the resistance here. And if you put this all into your calculator, you end up with a resistance of 36,125 ohms, or if you want to round it, 36,13 ohms.